Welcome to another episode on my pneumatic hand, robotic arm and wrist with pneumatics, pneumatic compressor and rubber interface controller with extension. Last time I focused on the yaw of the hand and more specifically the gearing and the wire. Control by wire. Now the yaw of the hand, which is more or less this movement, is being taken care of by this motor, a winch and two wires. This one and this one. And this one is going through a guide here, connected here. Now last time that I ran the program, apart from several sensors not working, the pivot not really working, not all the time, but the yaw didn't work at all. Even worse, these gears, perpendicular, just didn't work. The motor did, but the winch wasn't going along. So the idea is, why doesn't it go? Why doesn't it work? Is it too tight? Too much tension? I don't know. But one of the possibilities is that this guide should guide it more smoothly. So the idea is to use some kind of wheel or a pulley. But if you take a look at this one, just an idea, then it has to be put like this. But how does the wire go? On the outside or on the inside? Well, since it rotates like this, it would be like this, but as soon as there is no tension, it drops off. So this one, not really. Another idea is to use two wheels and then what? The chance is that if there is no tension, that it slips off the wheel and goes straight on the axis, on the axle. Which still does a nice way, but it doesn't really guide. Although, does that matter? Well, yes, because you want to have tension here. So, how do you avoid the tension to get relieved and still have it in the same place? Good question. This is kind of heavy and this currently won't work. So I can try the software a bit again, or more specific the diagnosis, because software just goes on without stopping, kind of. Let's try the diagnosis and see if with 1 speed, 1 second, I can get something to move. I did it last time, but a refresh of situation may be helpful. So let's do that for a moment. Open the interface. slave fourth motor. Well, input 3 is already detecting, that is nice. And now I already see that in either way it slips over the winch right here. It goes a very short way, just pulling it tighter, and that's it. So this is not much of a good situation at all, but how to improve it. So with the motor not really able to do anything, I think I will momentarily get it back. So now the motor is no longer connected to the winch, but I also will disconnect this side of the hand. Let's first see whatever result this has. Well, absolutely not much at all. This is still way too flexible. So I think the first thing to do is make this connection somehow, if possible anyway, but now I already see that there is a problem. Let me first take away this one. And this one, because this needs to be connected. Then these two are actually exactly the same, in the same position, and that should better not be. So what is the best way to proceed? When this is like this, this one should be the other way around. So and this side is easier to do. So let's do it like this. Through the hole. A little bit elevated. Alright, so this is better. And let's see whatever this brings, if it brings anything at all. So, right, and this disconnects immediately. So I really need to make a connection here. And after that I can see if manual operating can indeed do something like this yaw movement, because for now, no way. Another thing that I realize now that I am lifting the hand and move the arm in total, that this may not be the correct position, location for the whole yaw winch at all. Because when it is lifted, the the wire is much shorter than here. So there's no need to do this. I need to relocate this. But the big question is then, where? And this is already heavy enough with the hand, but there's no other choice. I really have to rethink the whole construction of the yawl. It's logical now that I see it, but yeah, this isn't This is not going to work at all. But what's the good location? So where would the whole yawl winch motor construction then have to be? Well, the only option is to build it somewhere here, since here is already a motor. And with this block I can connect this parts like this here, and this barely makes it. Even now there is some obstruction somewhere. Yeah, right here. Anyway, oh, I see. Already noticed what happened. One axis that has come. Alright, this is better. This works. And this also shows that with this axle on the elbow, this works nicely. So I can connect the motor here somehow. So let's disconnect, or try to disconnect this. And which also means that I have to rewire, but these wires have to go to the, oops, you can't see that. These wires have to go to the other side of the elbow. So let's take them away for now, like this. And then it would have to be somewhere like here. And that will have to be in one way or another like this. So that's a new challenge. How to come up with a nice construction that holds. Well, deconstruct here and build there. Let's see how that works out. So one option to mount it is like this, a frame attached to the lower side of the arm, to which the motor is attached and already rewired. The question is, of course, this is the winch, and the winch should be reversed since the gearing is reversed. So let's quickly see how that works out. Should be something like this. Don't mind the wiring for now. Anyway, put on here, but then the motor should be elevated to a position here, and then with a slightly longer axle it could be just right. Would that be indeed right? Well, the wires could be right. Anyway, there would be no more question about tension when it moves up and down, so that's a good point. So let's see how I can reconstruct the winch that it points this way and maybe elevate the motor a little bit. Part of new construction with the winch, now without wire, but that's just a detail. Longer axle to come closer here, so maybe another axle as well. But this would be one possible combination. Then this motor would be either further backwards or vertical. And vertical would take away the problem that it comes very close to the elbow axle. And here I can shift it up and down and have it touch this gear. So I think that would be a very nice idea. Then, is this solid enough or robust enough? Not quite sure. But, and there goes this connection. But this idea is anyway a start, and let's see if doing it vertical can solve this problem as well. Let's just see. I think that would be a very nice solution. So I think I will do just another reconstruction, upon reconstruction, to fetch it this way, and this would be looking like actually the way it was up here. Not like this, but more like this. Having here something that actually stabilizes this very flexible situation. Nice idea, hopefully executable. So let's make an attempt to see how that works out. So now I have made the reconstruction with the winch connected to the now vertical attached motor, including the wiring. But I just realized that despite the fact that this isn't wired yet, no problem, I can do that, but that's not important. What I just realized is that with two motors and this quite heavy hand as well, will the vertical gearbox be able to even lift the arm? So let me test that right now, and I have to check that with the vertical gearbox which is connected here to the first motor on the extension, which is motor 5 in the diagnosis. So let's see if that still works. And it does work. So although I had to use bit greater speed, but it does work. So I'm happy with that. Now I can also test this motor, which is motor 4 on the extension. So let's see if that works too. That is no problem, it's nicely wired. Next thing is of course that I have to make a construction like this one to keep the axis nice in line, to keep this one nice in line, because this one is flexible just like this one is. And that is next part of the reconstruction. So let's see how that works out. Do I have to do it here or there? I think this is better. As you can see, I have made construction here on top, and I had to use this covering piece because the distance between these two blocks is a little bit too small for a small piece like this. So I hope that is robust enough to keep everything in place. Same thing goes here for. I better put some nice construction piece here, but it's all to see if things can work. So let's run it again and see if this holds. Which is extension 4. So far that works. And how about this one? So here I have a little bit doubts. But it still manages, although let's see. It doesn't make an impression on one of the upper switch. And in the end it has a little bit of a problem going all the way down. So the vertical gearbox has a little bit of a problem, with this weight. How to solve this? Make the vertical gearbox robust or make another solution entirely? And I think I have to deal with the vertical gearbox because I would not know how to deal with the yaw gearing and motor location in the other way. There's very limited space. Although the setup of the vertical gearbox is not ideal, it is the way it is, and I don't like to reconstruct that one because then taking that one apart is a whole different chapter, a whole different story. So I think I'll have to deal with that, and I just see that the part where the vertical gearbox string is attached is kind of bending through, so maybe that needs a little bit of reinforcement. But overall I am rather satisfied with the present solution where it comes to the yaw motor and gear. So let's see where we get this program wise. So, piece of software. This is the vertical gearbox, and it's motor 5, and as you can see it runs with speed 2, and as I have found out that may just be a problem touching the switches, because I added now the motor to the arm, the yaw motor. But let's see anyway if that works. And then first I have to close the interface. Now let's see whatever happens. If anything happens, because okay, yep, and there is the problem. It just doesn't make it. Let's do it again. And if I give some manual assistance, what happens then? That works. And now without aid it works. It doesn't come easy at all, but it does work. And now it gets stuck for some reason. But initially it does work. So this means that I don't have to change the program. And the problem that it doesn't work now, let's see if the switch is touched anyway. No, it's not touched. No switch has been touched. So that is a problem. It may be a problem of just the switch not being detected, or actually not being touched. But I doubt that it is being the touching, because it has reached its ultimate position. So it must be the detection. But I don't need to change the program, that's one thing, and I needed to know that. So, happy for this one. So for the last part of this episode, once again a full test, and you can already see that things don't go as intended, because the wrist isn't fully working. This one, the yaw motor doesn't run, and the only thing that is really working is the base pivot. Is this a problem? Well, we can always see if I can stimulate something. Yes, I can stimulate. That has to wait a little bit and then go back. Oh, and that actually runs. So the wrist pivot works. And then this one works. So that actually works out nicely. Now I do hope that I've wired it correctly, but as far as I can see, with a little stimulation of the wrist pivot, it may work out. Only the vertical movement, not so much. Thank you for watching. If you like this video, please subscribe to my channel if you haven't done so already. Give it a thumbs up, leave a comment, very much appreciated. You can also follow me on Twitter, retweet and like, leave a comment, and you can also follow me on Instagram and like it and leave a comment. Very much appreciated again. Please donate to keep videos coming to you. Much appreciated. Takes money. Well, money of course, electricity, etc. But also time. You can also become a patron and have your name mentioned depending on the pledge you make. And this is going to be continued. Bye bye.